This video, we are still within our periodic function activity, but we're going to be focusing on our sort of key attributes that a periodic function has that are maybe different from some of our other function types we've looked at in college algebra. So the three sort of key features we're going to focus on are the midline, amplitude, and frequency. We already discussed the period in the previous videos, so if you didn't watch that, you might want to go back and take a look at that. So we're going to start with the midline. So the midline is a line, I'm going to stress that it's a line, that lies halfway between the maximum and minimum output values of a function. So in it being a line, it is a horizontal line, and so we do write the equation sort of y equals the midline. Now, we want to know, how do we find this midline? So we're going to look at it both graphically and from a table and try and be like, okay, well, how do we find the midline in each of these situations? So I put a copy of that graph from the first example A right down here. And I noticed, remember, I have a max value up here at 2. And I have a min value here at -4. Now I can do this algebraically, but sometimes with a graph, I like to just sort of do it graphically. And so what I'll sometimes do is, okay, well, I go up 1 from the minimum. That puts me at -3. I go down 1 from the max. That puts me at 1. I go up 1 more. I go down 1 more. I go up 1 more, and I go down 1 more, and I meet. And sort of where that halfway meeting point, that becomes our midline. And I like to draw it in as a dashed line. And so looking here, that means my midline is occurring at y equals 1. And so if I have the graph and it's nice enough to be there, I can really just look at the graph and say, okay, what's halfway between that max and min value? Now, let's say I wanted to have a more algebraic way to get there. There's a few different things we could do. So we said, okay, we had our max value at 2 and we had our min value at -4. And so if it lies halfway, you could almost think of it sort of like, it's an average or a mean value of your sort of function. And so if I wanted the average between, output value between my max and my min, I would do 2 plus -4 and divide it by 2 because I have two values. And 2 plus -4 is -2 divided by 2 is -1, which was our midline. And I was at -1 and I didn't write it there. And so this is another way of sort of determining my midline is I find the, mean value, the mean output value between my max and my min. All right, so we can use that idea with our table part B question. So, if I go back up really quickly, remember we identified the min value was 7 and the max value was 27. And so if I wanted to sort of find that mean value between the two, I would do 27 plus 7 divided by 2. 27 plus 7 is 34. 34 divided by 2 is 17. So that's one way to sort of just use numbers. I sometimes do it a little differently. And what I end up doing is I actually find the distance between my min and my max. And so to do that, I would take 27 and I would subtract 7. And I'd say, okay, well, these are 20 units apart. Well, the midline occurs exactly halfway between that. Well, what is half of 20? Well, half of 20, this is sort of a different way, let's see, is 10. So I need to go 10 units up from my minimum value or 10 units down from my maximum value, whichever sort of way you want to think about this. And so if I do 7 plus 10, so I have sort of my min plus, the halfway distance, guess what? I get my midline of 17. And so this is just a different way of thinking about this. And you'll notice on the next sort of page of this activity, I have both of these sort of formulas written out for you. And it sort of gives you the definition of, what is a midline in your two different ways. Don't forget that sort of y equals there. Now, what you're actually finding when you do that distance between the min and max and half of it, it actually has a special name. This right here is our amplitude. of the periodic function. And the amplitude is the distance from the midline to the maximum output or minimum output value of a function. So I like to think of it's half of the distance between the max and the min is another way to sort of think about this. And so there's, we just talked about one way to do this, but I can do it graphically like I sort of looked at the other one. So remember, we found that our midline was at -1. And so our amplitude would be the distance between our max and our midline. So I like to sometimes graphically sort of show what that represents. So, the midline or the min. And they should be the same. If it's truly periodic, those two, whether I go from the max to the midline or the midline to the min, I should get the same number. And notice 1, 2, 3, or 1, 2, 3, both of them have values of 3. So in this case, our amplitude is 3. And I can check this algebraically. Remember, we talked about that sort of that max minus min would get us our amplitude. And so max here was 2. Oops, I don't want a parentheses yet. Minus our min divided in half. So 2 minus a -4 is actually 2 plus 4, which is 6. 6 divided by 2 is 3. Another way to think about this is also sort of how you look at it graphically. And that would be, notice that this is really the distance between our max and our midline. So if I did max minus our midline, I would have 20, oops, I'm thinking the wrong problem here. I would have 2 minus a -1, which would again equal 3. And so all of these are different ways. I could count from the graph. I can sort of look and find the total distance and then divide it in half. And then I could find the max minus the midline. Sometimes, so let's try out these different strategies from sort of our table problem. So remember, our min was 7, our max was 27. I like to just sort of highlight those. So if I went sort of the route of max minus min, that was 27 minus 7, all divided by 2. And then that would equal 20 over 2, which would equal 10. And so going back up to that previous example, remember that right there was that special, we found the amplitude. Now, another option, here we did max minus midline. You could also do midline minus your minimum value. And so remember, in this case, our midline was at 17, and our minimum value is 7. And so if I do 17 minus 7, I also get 10. And so all of these are different sort of ways to figure out the amplitude. And I sort of summed it up here. Now notice here I just did the max of f minus the midline, but we could also have the midline minus the minimum of f, sort of, what works for you. And where your brain goes. So I tend to find the amplitude first and then use it to find the midline. And that's where this first formula is super helpful and handy. But I know other people who like to find the midline first and then they use the midline to find the amplitude. Find a strategy that works best for you. I'm trying to sort of give you some tools and, tips and tricks. All right, the very last sort of key feature we're going to focus on today is known as the frequency. And mathematically, it's just the reciprocal of the function's period. A reminder, a reciprocal is 1 over a number. So in this case, this would be 1 over the period. And you can sort of think about it, it's basically the number of times the cycle completes in a specific amount of time, if time's the input. And frequency is measured in numbers of cycles per input unit, number of cycles per input unit. So we have sort of an example here. If we had a function that repeats itself every 24 hours, then the period would be 24. The frequency would be 1/24. There's one cycle per 24 hours, which means in an hour, we complete 1/24 of our cycle. Now, thinking about that with the functions we just looked at. In our first graphic function, remember our period was 7. So our frequency is 1/7, which means it completes 1/7 of its period for 1x unit. And you can sort of like, if I look at the graph, what I could think about is, okay, this single stretch right here is 1/7 of this entire period because it's 1x unit. So that's 1/7 of the period. Um, right here, that's 1/7 of the total bit. Um, and so in the other one, we had a period of 4. So the frequency was 1/4. It completed 1/4 of the period each unit we went by. Now, some people ask, well, what if you had, and I'm just going to do an extra little example down here. What if we had something like you had a period of 1/2. Okay, so every, 1/2 an hour, our pattern repeats itself again. What would be the frequency? Well, technically the frequency would be 1/1/2. And if you think about that mathematically, that becomes 2. Well, this actually makes total sense because it's basically saying, okay, you would complete 2 cycles per hour. If in a half an hour you complete 1 cycle, then you're going to complete 2 full cycles in an hour. And so that's another sort of way to think about frequency. Hopefully this gives you a sense of sort of the 3 key features in addition to period that we're going to be looking at within our periodic functions. The next page goes into some examples. Try them on your own, and then click back and watch my video solutions sort of walk through how I reach the answers with them.